Okay, thank you very much. Well, you all seen the show last night. So now Ben Pickard and Tamas Nepusz are going to go through the challenges of a drone light show. Over to you guys.
Cheers, guys. Good morning, everybody. Thank you for attending this talk. And today we're going to talk about the challenges of a drone light show. So I'm from a company here in the UK called Light Dynamics, and I'm joined on stage by Tamas, who leads on the technical software development side of our partner called Skybrush, based in Hungary. Hopefully you enjoyed the show last night. This talk couldn't be... Thank you. This presentation couldn't be any more aptly named other than the challenge that we faced last night. So glad we got airborne, but a few challenges nonetheless. So a little bit about Light Dynamics firstly. So we're a UK-based manufacturer. All of our hardware and equipment is manufactured in the UK. Yes, there are items that we injection mold, etc., out in China, but most importantly, all of the PCB development, the pick and place, all of that assembly is done here in the UK. We've got a growing company, about 6 employees now. We're manufacturing these in-house. We've got 2 sort of core products on offer, which I'll get into shortly, essentially being the Pixel Light Show drone, which is our flagship drone, and the larger brother, soon to be released, the Pixel Pyro. We are authorized by the CEA here in the UK, as well as the FAA in the US. We've got a licensed manufacturing partnership out there, so we're producing actively in the UK and the US. And as I say, the light show industry is certainly growing well. We're certainly nowhere near its peak yet. What's great about that is that as an RG pilot community, we're testing on mass scale every time we fly. We're not flying single drones. We're typically flying tens, hundreds, and in some cases thousands. And so that provides an awful lot of data to work off, rightly or wrongly. We've got approximately about 50% UK market share in terms of active light show operators here. We never envisaged the UK to be a market, if I'm honest, hence why we focus so heavily on the US. And so we're very pleased that we can actually make some traction on the doorstep. Just for reference, we're based in Nottinghamshire. It's about 2.5 hours south from where we are presently. So at the core of our development, right when me and Mark started the business, in order for us to remain competitive and offer a product that we could produce on scale reliably, the key part was to develop a motherboard. And so there are a number of key components that go into making a light show system work, primarily being the flight control system. So we've now got our own STM32H743 based directly on the board, integrating an F9P GNSS, and a ESP Wi-Fi module. We're just transitioning into using ESP32s. Essentially, the drones are running in a private Wi-Fi network. And so each drone is essentially an IP address, and we correlate that to match the system ID in RG Pilot. When it comes to stitching anything more than 250 drones together currently, we end up running parallel networks in different subnets, etc., etc. Sorry, I'm losing my mic here. Tamas does some rather clever stuff in Skybrush that allows you to add some ID offsets in. We're hoping that one day we'll get round to some 32-bit SYS ID. We also have an SIK radio on board for secondary communications. We've got LED and pyrotechnic outputs from servo channels. And so what's quite unique from a manufacturer is that we've now been able to the motherboard so that the hardware internally is the same from the Pixel and the Pixel Pyro, which streamlines our manufacturing process massively. One of the really, really unique features of our systems when we first developed it was the whole remote on-off feature. We're no longer talking about laying a single drone out in the field, plugging a battery in and flying. We're talking about tens, hundreds, and thousands. And so, as we all know, traditionally the standard for turning a drone on and off is the battery connection. If you get a little bit excited and set up a show 4 hours prior to takeoff and you don't want the drones to sit there burning power, previous walks of life, people would have to go around and physically remove all. What we have collectively developed is our rather unique remote on-off feature. So essentially when the drone is battery is inserted into the drone is then sat in a sleep mode. And essentially that's using 1% of battery per hour. The drone is then registering on its network, appearing in Skybrush, and then, you imagine you've got, 500, 1,000 drones all laid out in this standby mode. We can click a single button in the GCS and all of the drones turn on. So nobody has to move a foot essentially at that point. Secondly, that correlates to a quite a unique flight termination system, which is completely independent to the flight control, as demonstrated last night. Essentially, we have using a GPIO on the Wi-Fi module, we're able to essentially pull power from the main board. So the reason why that's quite unique, and it's becoming a requirement in the EASA for an independent flight termination system that's different to just a disarm command via the flight controller, is that, if the EKF is in completely a confused state and it is not responding to commands, yes, clearly it still requires a Wi-Fi connection to be functional, but essentially we can just pull power. So we did have a couple of drones go a little bit AWOL last night, and fortunately procedures all worked and technology all worked as expected, and so we were able to terminate those drones in our sterile ground area and then literally pick up the pieces afterwards. But ask any operator, we'd sooner take that all day long than risk the potential of a drone going outside of our sterile area. So safety is at the utmost importance here. So this inner workings here is really what helped the business and the product feasible. As I mentioned, this is manufactured in the UK. So we actually manufacture these boards in Lincoln from an ISO 9001 certified facility, really to increase the reliability and optimize assembly times. But it's fantastic to be able to support this product from home soil. Yes, we're manufacturing in the US as a license under license, but everything is homegrown here from the UK in Lincolnshire and Nottinghamshire. In terms of the product themselves, so we have Pixel, which is the smaller of the two. This is a 400-gram all-up-weight system. I'll leave these on the desk on the side so people can take a look afterwards if they want to. Both of these systems are operating from RTK. With the F9P GNSS, we're able to get down to centimeter level of accuracy, which we given the size of the drones, we're actually taking the drones off at a 0.5 meter spacing. So the drones are laid out on the ground at every 50 centimeters, and they then take off in trays to maintain that separation in the air of typically around 2 meters. We can get down all the way down to 1 to 1.5 meters in transitions in flight, but essentially that means with 1,100 drones, which you'll see a little bit later on in this presentation, we can lay out 1,100 drones in a 28 meter wide by 10 meter long ground area. So incredibly compact. 0.5 meter is just enough space to allow you to walk through the columns as well without tripping around too much. We've got dual C2, so Wi-Fi is the primary and the SIK secondary. We've got quite a unique 2S lithium-ion smart battery, which we developed again in-house with a compatible multi-port charger. So again, operating tens, hundreds, thousands of drones is so far detached from operating a single drone where you can get away with just plugging it into your smart charger, inputting a few values and off you go. We really need to look at the whole process in terms of how we're handling, storing, managing, maintaining, and obviously assembling the drones itself. So it's a much, much bigger picture. And just out of interest, we can get a maximum show time of 15 minutes from the smaller drone. We then also have the Pyro, which is soon to be released. We've now received CAA certification here in the UK. And so we can essentially launch 4 pyrotechnics off the drone independently. They can be triggered simultaneously or independent points throughout the show. Again, that's a nice feature that's been integrated through into Skybrush. It's got a 400-gram payload capacity, and again, can operate for a maximum show time of 15 minutes at its maximum takeoff mass. The other way to look at that is it's still got an LED on the bottom of the drone. So in the sky, it's still functional as a light show drone. And some operators can use this as a standalone light show drone with no pyro attached and then get extended flight times up to 25 minutes. So going back to the battery charging, this is our rugged battery charging case. It can charge 20 of our smart batteries in about 1.5 hours. It's got an onboard. The batteries itself have got a BMS, which manage that balancing of the cells independently. They're a 5,000 milliamp hour battery. And essentially the Pyro drone, again, looking at the bigger picture, the Pyro drone and the Pixel drone both use exactly the same battery. The only difference is that in the Pyro drone, we run 2 of the batteries in series. So, you've got complete control of your fleet management. You've not got independent battery chargers and batteries per different aircraft. So just taking a step back, we're always trying to look at this bigger picture and how the customer is going to be interacting with the equipment, because it can be a nightmare. So in terms of operating and the challenges attached to it, clearly you've got an extrapolated risk factor. You're no longer operating in a single drone. There are 1,000 times the chances of things going wrong, given that, multiplied by X, depending on how many drones you're operating. You've really got to be considering the transport, the handling, the storage, assembly, and maintenance of these drones. And the challenge becomes when you're operating anything above 200, 250, depending on how you're configuring your networks, you then need to start stitching, we call it, multiple networks together in what we call a parallel network. And so, crew fatigue, technical challenges. Last night we had our router completely lock up prior to flight, which is why we ended up getting some gaps in the show. We couldn't get another 20 drones attached to a new router in time quick enough, so we just had to, pray and hope for the best really at the end of the day. And typically in this kind of scenario, you're operating to a deadline, to a timeline. London New Year's Eve, you couldn't expect anything really to go wrong, surely. And so what we're trying to factor in now is multiple states of redundancy and how we can pull out these teething issues. And yes, we're looking at onboard stuff we can do on the drone, which we'll come into shortly. I mean, some of you guys in the room have been working with us directly to develop, enhanced fail-safe features. But there's still way more we can go at here, and we're just hoping that we can help. We have hopefully assisted helping identify some EKF and dual RTCM passing optimizations in the past, and we're really excited to keep that going, essentially. But actually, when it goes well, this is an example of 800 drones we were flying back in California in April, I believe. And actually, this is a Lord of the Rings theme show. And when it's executed well, we had 100% takeoff rate in this particular show, and it looks stunning. So this, just to give you a sheer idea of scale here, that formation you're seeing on the screen right now is 350 meters wide. So we're covering a large area. That's the dragon from Lord of the Rings. We had so this is about a 12-minute show. We had a smart return to home feature. So one of the really key things, one of the key questions we get asked is that, do you need to place a drone on the ground on a particular spot? The answer is no, you don't, thanks to these guys. And so the software, as long as the drone has got RTK positioning and you've laid out your grid correctly, the ground spacing, the software is then able to work out what drone is placed on which pad and calculate the trajectories that it needs to upload to that individual drone as part of the show upload process. And the smart return to home feature is essentially allowing the drones to return to the exact spot it took off from. In many shows, the drones do not land at the spot they took off from, and that's kind of irrelevant, really. But it can be quite nice for fleet management, particularly if you've got multiple subnets stitched together. Then they can all go back away in their individual carriers. So what's next before I hand over to Tamas, in terms of where we would like to see this go? And I'm conscious I didn't want to bombard you with requests here, but certainly support for more SYSD capabilities. Are regularly operating beyond 250 drones, and that would certainly simplify our manufacturing lives a lot easier. And actually, key things as we demonstrated last night, specific fail safes and automated. Fortunately, we've been operating for some time now. We're able to identify these potential rogue drones long before the event happens. We just need to try and take action at the right time so it then doesn't interfere with something else within the swarm. So yes, we can identify a drone that's perhaps looking a little bit unhappy, and we just need to make sure we can interact with it at the right point in the show. I'll just open up the floor for some quick Q&A while Tamas gets his presentation running, if that's okay. Any questions?
Who's first?
Just wondering what are the most common reasons that, like, if you see one drone in the show or two drones in the show wigging out, what are the most common reasons for that? What are the most common failures that you see?
Yeah, so most common failure is down to the compass drifting. Essentially, we get toilet bowling. 90% of the time, a compass toilet bowl will recover itself and come back. We're very, very keen to explore how we can potentially remove the compass altogether. That. It is by far our most unreliable component within the platform.
I figured I can help you with that.
Okay, fantastic.
Yeah.
You probably saw on my talk a lot of the discussions about the follow me, the S-curve kinematic path planning. What level are you going to with your path? Like, what are you, I assume you're using guided mode commands to convey your path?
Yeah, I think I can respond to the question. So basically what we are doing, I will talk about it a little bit later. We have our own drone show flight mode, which is using the guided mode behind the scenes, and we are updating position and velocity set points about 10 times per second. So we are not using the S-curve thing directly. The representation of the path that the drones are flying is a sequence of Bezier curves. So it's already smooth, and it already ensures that the points where the segments connect to each other, they have their velocity vectors aligned. So for our purposes, just using the guided mode directly and constantly updating the set points is enough.
So if you're using guided mode, you are using the real-time S-curves. What command are you using? Position, velocity, acceleration commands?
We are using position and velocity commands. In the firmware, there's an option to use either just plain positioning or position and velocity, or position, velocity, and acceleration. We don't use the acceleration part because the designers are usually working in external software where they're working with straight lines, and we can only go up to Bezier curves, so we don't really get useful acceleration information. And if you are using plain position control only, then what we see is that the drones are essentially lagging behind all the time compared to where they should be. And it feels like, it's like slow and damped down compared to what the designers originally had in mind. And position and velocity seems to be a nice compromise between the two.
Exactly, and that was the heart of the question I was asking. So when you're running a position only error that grows with velocity. If you have position and velocity, you'll get a velocity error that grows as you change the velocity thing. So I was wondering at what level you needed to go to achieve the dynamic change in shapes that you're following and the curves that you're following. So thank you.
Great presentation. I was curious on for swarm recovery if you need to replace a drone in during the maneuvers, what does that look like? Do you support that now? And if not, how do you think you could solve that?
So in terms of replacing a drone, if we identify a problem on the ground, then we can essentially pull that drone out of the show, swap another one into its place, and then just recalculate the show's mapping very, very quickly and re-upload the show directly to that new drone, essentially. So it is a very quick process.
As the if a drone has a failure in flight, how quickly, if they're at normal operating altitude, is from the time you recognize the failure until the time the next one launches?
Essentially, it depends what the failure is and how we're able to react. If we can, we'll try and go for a designated land command. The challenge is if it's GPS, for instance, it could be landing on a trajectory and looking like it's drifting outside of our sterile ground area. The quickest way to interact is essentially do that flight termination command and just pull the power to the drone and physically pick up the pieces. Again, the cost of a drone versus the cost of not being able to operate and the risk of not being able to operate is greatly outweighed. But where we can, we'll always go for a landing. The guys have recently implemented a bubble geofence, so essentially all the way around the trajectory of the individual's drone's flight path, we can define in the parameters from RGPilot at what point we want, if the drone's drifted beyond its trajectory, we can tell it's going to an automated landing. The challenge with that is that you have no control because there's no intra-swarm communication. You've got no control on what could that then interact with on the way back down.
Got it. Thank you.
If I could just interrupt, if we can pause the questions for the time being, let's let Tamas do the rest of his talk for now, and then we'll resume taking questions at the end of this time. Thank you.
Hello, everyone. Thank you for coming to this talk and listening to the deeper challenges that we have in implementing a drone light show. What I'm going to talk about is the software side of things. I initially wanted to make this talk really, really deeply technical. But when I was writing my slides, I realized that there are just so many things to explain and introduce that I think I'm just going to scratch the surface. And then if you have questions, then sure, just catch me in the corridors later on, and then I will be happy to explain everything. So a little bit about myself. I'm a computer scientist, got my PhD in artificial intelligence, and then I became the lead developer of Skybrush, the drone show software. I'm also the CIO at Colmot Robotics, which is a Hungarian startup that acts both as the manufacturer of Skybrush itself, but we are also working in other projects with swarm-related applications of drones. So what we really do well is not when we have one drone, but when we have tens or hundreds of them. And I think it's the best way to introduce Skybrush to you guys is to start with a demo. So what I'm going to show you is running a 100 drone show in simulation at roughly the same location where we were taking off from yesterday. That show was with 200 drones. My computer is unfortunately not able to simulate 200 drones in real time. So I'm just going to start up. Oh, sorry. Yep, now it works. Okay. So what you see here, there's two halves of the screen. The top half is a Skybrush server. This is the part that is communicating with the drones behind the scenes. What you see at the bottom is 100 instances of ArduPilot Fiddle running on my machine in parallel, simulating 100 drones. I tried it with 200, it didn't work. With 150, it was sort of okay-ish, but I thought it's better not to risk it for the presentation. And I'm going to start Skybrush Live now. Hang on. Okay, now it's working. Yeah, so this is the user interface of the actual software that we are using on the site when we are running a drone show. You can see 100 drones laid out on the field where we took off from yesterday. And what when everything goes well on site, the only thing that you need to do is to click there in the show control panel, open the show file. System parses the show file. Okay, it needs some permission to access the folder. Yep. And then if all your drones are laid out in the field according to how the show is planned, then you just click on this magic wand icon, and then the system fits the takeoff grid of the show to your actual layout, and a view like this on the map. The yellow area is the area where the drones are going to fly during the show. This is not the show that we flew yesterday, so we didn't actually fly over the river. We were just flying above the takeoff area. Then you need to ask the software to figure out which drone is going to fly which trajectory. This is again just one click of a button. Then you approve the layout. This is like a checklist that you need to go through in order to start the show. You set up the geofence, which is created automatically around the convex hull of the show area with some padding around it. Then you do the upload. This is usually not this fast in the field, but if you have a good Wi-Fi network, then it is supposed to be. I mean, with a 2,000 drone test, we managed to reach about 800 drones per minute as an upload rate. So that's quite good. We had to use more threads, and it was a very beefy wireless network, but usually the upload process shouldn't take more than 2 to 3 minutes. Once it is done, you check that none of your drones are showing errors. There's a manual pre-flight check that you need to go through and tick each of these fields. I actually turned this check off for demo purposes because I don't want to do that. And you set a start time for the show, 15 seconds from now, set start time, and then you authorize the start of the show. And all the drones are receiving the authorization bit from the ground station, and then in 1 second, they should start their motors in phases and then start flying the show. So this is how it looks like when everything goes well on the field. The only thing that I haven't mentioned is that we need to use RTK corrections for the accuracy that we need for the drone show. So there's an RTK base station next to us, and then we also transmit the RTK corrections to the drones. I'm going to close this now and move on with the rest of the presentation if I find that window. No. Okay, where were I? Okay. So yeah, most of you are engineers. So I guess this all means nothing to you if I'm not showing you how we do this. So the nice thing about Skybrush is that its core is entirely open source. So we have an open source ArduPilot fork that adds the drone show flight mode and adds several safety features on top of ArduPilot that make it possible to do this with this flight controller. The front end that you have seen, it's also completely open source. It's written in TypeScript and React, and you can download it. You can build it for yourself. You can tweak the user interface, which operators actually like very much because sometimes they just feel that they need to hide some of the complexity, some of the configuration opportunities that our software gives to them, and then they are free to just go in and then hide whatever they want, things that they don't want their pilots to mess around with. And the server itself, the part that is communicating with the drones, that's open core in the sense that with the open source part, you can safely run drone shows up to roughly 750, 1,000 drones. And at that point, you start reaching certain performance limits, which can be overcome by replacing certain parts of the server with more performant components written in Rust. And that part is not open source. So if you just want to run shows up to 1,000 drones, you're probably okay with the open source part. Beyond that, you will need a license and get the more performant components. But of course, even if you are running shows with just 100, it is well in your best interests to share some of your revenue with us in order to keep the whole project going. And let's talk a little bit about the show design process. So when we are designing a show, we have a plugin for Blender, which is like a generic 3D artist software. And our plugin allows you to design the trajectories and the light program for the drones, and also design the transitions between the formations. So you as a designer only have to be concerned about the formations themselves, and the transitions between them are figured out completely by the Blender plugin. It also provides real-time safety validations. So the blue dots at the top that you see on the screen, those are altitude warnings. Those drones are too high compared to the altitude limit that is configured in the software. We have real-time warnings for proximity issues, like two drones being too close to each other. And we also have velocity and acceleration constraints that are validated in real time while you are working with the software. And when you are done with designing the show, you need to export it into a single show file, where the extension is SkyC, but it's actually a zip file. A zip file containing a bunch of JSON files. There's like one JSON file for each drone with the trajectory of the drone, one JSON file with the light program, and there are some auxiliary metadata files in there. It can be produced by hand from any other software if you want to, but we provide the plugin for Blender, and this is what works the best. And once you have the show file, and also, of course, and we also support Pyro drones since 2017. So this is a New Year's Eve show from 2017, back in the old days when RTK was not common. So you could see that the safety distance between drones is much larger than what you are used to nowadays. And I think we also managed to set half of the airfield on fire at this time. So I'm not going to mention where this was, but Pyro is a dangerous thing. So it shouldn't be taken lightly. So when it comes to the show execution part, this is the most interesting part for me because lots of logistic problems arise on the field. So in IKEA style, for a drone light show, you need, of course, you need the drones. You need lots of batteries. I mean, in practice, you need at least twice as many batteries as the number of drones because sometimes you are just doing practice flights and sometimes you just forget to charge them. So it's good to have at least twice as many as the number of drones. You need 2 ground stations, one primary and one secondary. Secondary is for the case when you trip over the primary one or anything breaks there. You need one RTK base station, which needs to be surveyed in before the show, and then it sends the RTK corrections to the drones. You need access points. For 200 drone show, you're probably okay with 2 access points, but as you have more and more drones, you need more and more wireless access points on the ground to cope with all the traffic from the drones. You need backup radio. This is a standard Holybro SIK radio. Any sort of radio would do that allows you to broadcast commands and RTK corrections to all the drones. They don't need to talk back over the secondary channel. That is left for the Wi-Fi. And what you don't need is a remote controller, which is crazy scary for me. But no one uses remote controllers in this industry nowadays. Back in the early days, we had remote controllers. We could switch flight modes from the remote controller. Somehow it just fell out of fashion. So this is how it works now. Okay, I'm going to skip a preparation part because you have seen it, how I've done it, and Ben was also talking a little bit about it. The point is that the most annoying part of the show is when you have set things up, you uploaded the show, and then you still have 2 hours to the start of the show because all the things start rushing on your head. Oh my God, what I've forgotten to do, what could go wrong, and things like that. This is the worst part of doing a show. Once you are past the takeoff phase, then it's pretty great. On board, we have a compact binary format storing the trajectories less than 10 kilobytes for a typical drone show. The trajectory is represented as a sequence of Bezier curves that are evaluated in real time to provide position and velocity set points. The light program is a bytecode with commands like set color now or start a fade to this color in this number of seconds. And we are simply using guided mode behind the scenes, and the set points are updated at 10 hertz. RTK corrections are injected on both channels redundantly, and then we deduplicate the packets before we forward them to the GPS. And we also have a compact telemetry stream similar to the high latency Mavlink packet, extended a little bit to contain more status bits that we need for the ground station. This is the important bit. This is what I really want to talk about. So the safety enhancements that you need for drone show. First, we have real-time drift warnings. So each drone checks how far it is from its set point and then shows you a warning on the screen when a drone is somehow drifting off the trajectory, which could be a result of bad show design, like when the designer is asking the drone to go 5 meters per second in one direction and then stop immediately. Of course, it will drift and then compensate back. That's normal. But when you have misbehaving drones, then it's very easy to identify them from the ground station. We have something called the hard geofence, which is a secondary geofence around the primary geofence. And if the drone hits the secondary hard geofence, it turns off the motors and falls down. This is something that is mandatory. So it is required by the CAA in most countries. And we also have the bubble fence that Ben mentioned, which I think is a better idea than the hard fence, but it's not mandatory at the moment. The bubble fence basically disarms the drone or sends it to land mode when it is too far from the planned trajectory. So you set up a bubble fence with a radius of 2 meters and a timeout of 3 seconds. And if the drone has drifted from its trajectory by more than 2 meters for more than 3 seconds, then it will either land or just disarm itself. Some people also use disarm on EKF failsafe, which is a pretty drastic thing to do. But for shows with thousands of drones and when there's more money on the line, and the audience is close, then this is the safest thing to do. And finally, my Christmas wish list for the Mavlink developers out there. These are the things that we would love to have in Mavlink in order to make things easier for us. First is, well, Ben went with a 4-byte Mavlink system ID. I would be happy with 2. So if we could have 2-byte Mavlink system IDs, then we wouldn't need to partition our drone form into separate Mavlink networks to get over the 1-byte system ID limit in Mavlink. So it would be great. It would be great if we had error messages from the drone when we are trying to set a parameter that doesn't exist. Because right now, when you do that, you just don't get any response from the drone at all, and it's hard to tell whether you're not getting a response because the parameter doesn't exist or because the wireless network sucks and the packet got lost somewhere. So that's not that great. And the last thing that I would really like to have is broadcast file transfers, which could be used for firmware updates on thousands of drones. You upload an ABIN file to all the drones at the same time, and then you just reboot them, and bam, you have a firmware update on 1,000 drones. Or you could upload the entire show, all the trajectories of all the drones to every single drone, and then you can leave it for later to decide which drone is going to fly which trajectory, because they all have the entire show. Right now, each drone receives only one trajectory when we do the upload, because it would be just too much data to push through with unicast file transfers. If we had a broadcast file transfer, this would be great to have. Okay, so thank you for your attention. And now it's the time for the questions. There's a 300 drone show running on the screen. So the more questions you ask, the more time you have to watch the show in the meanwhile.
I'm very sorry, we do not have time for questions. My apologies. Please tie up with Ben and Tamas in the lunch break.
Okay.
Sorry. Thank you very much. Fantastic talk. Another round of applause. Okay, if I could ask everyone to please stay seated, we'll do a quick changeover, ready for Sid's talk.
Thank you for joining us for the RGU Pilot Developers Conference 2025. With thanks to our sponsors, 3DXR, Aerosystems West, CUAV, QPilot, High-Tech, Polybro, IR-Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model, and Theseus. Organised by KH Unmanned. Hosted by 3DXR in North Yorkshire. Broadcast by Q Branch.